Hello everyone, myself Tanvi Patel, working as Assistant Professor in Computer Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. We have continued with our first chapter, that is Introduction to Computer Networks and Internet. Today our topic is difference between OSI and TCP/IP model, design issues for the layer and addressing. First of all, difference between OSI and TCP/IP model. In OSI, it is a generic protocol independent standard acting as a communication gateway between the network and end user. And in TCP/IP model, it is based on standard protocol around which the internet has developed. It is a communication protocol which allows connection to host over a network. In OSI model, the transport layer guarantees the delivery of the packet. Means the transport layer which is there in the OSI model, it is being guaranteed that the delivery of the packet is perfectly to the receiver. In TCP/IP model, the transport layer does not guarantee delivery of packet. Still, it is reliable. In OSI model, it follows vertical approach and TCP/IP model follows horizontal approach. OSI model has a separate presentation and session layer. In TCP/IP model, there is no separate presentation and session layer. Transport layer is connection oriented, while in TCP/IP model, transport layer is both connection oriented and connectionless. Next, network layer is both connection oriented and connectionless, and in TCP/IP model, it is only connectionless. OSI is the reference model around which the network are built. Generally, it is used as a guidance tool, and in TCP/IP model, it is a way implementation of OSI model. Network layer of OSI model provides both connection-oriented and connection-less services, and in network layer, TCP/IP model provides only connection-less services. OSI model has a problem of fitting the protocol into the model, and in TCP/IP model does not fit any protocol. Protocols are hidden in OSI model and are easily replaced as the technology changes. You can change the protocol in OSI model as the technology changes, while in TCP/IP replacing protocol is not easy. In OSI model, it defines services, interfaces and protocol very clearly and makes clear distinction between them. It is protocol independent, while TCP/IP model, it is protocol dependent. In OSI model, there are 7 layers, and in TCP/IP model, there are only 4 layers. Now next is design issues for the layers. A number of design issues exist for the layer-to-layer approach of computer network. The main design issues are reliability, scalability, addressing, error control, flow control, resource allocation, statistical multiplexing, routing and security. So first is reliability. Network channels and components may be unreliable, resulting in loss of bits while transferring data. So an important design issues to make sure is the reliability. The sender who is sending message to the receiver is getting the message or not, that is the main purpose of the sender. So the network and channel, which is the main path between the sender and the receiver, that should be reliable so that the receiver gets the message which is perfectly sent from the sender. Second one is scalability. Networks are continuously evolving. The size are continuously increasing, leading to congestion. Also, when new technologies are applied to the added component, it may lead to incompatibility issues. Means the components which you add as the technology changes, if you add some component, then there must be some issues of incompatibility changes. So that should be reliable. Next is addressing. At a particular time, innumerable messages are being transferred between large number of computers. So addressing is the main purpose. The sender who is sending the message or packet to the receiver, the addressing is done perfectly so that the receiver gets the same message which is sent from the sender. Next is error control. Unreliable channel introduce a number of errors in the data stream that are communicated. The channel which is unreliable, it will generate error, and the data which is communicated should be possibility of error. So the layer need to agree upon a error detection and error correction method. So there should be one error correction and error detection method so that the packet transfer should be perfectly. Flow control. If the rate at which data is produced by the sender is higher than the rate at which data is received by the receiver, there are chances of overflowing the receiver. So the data which is sent by the sender, that should be same which should be received by the receiver. If it is higher in rate, then there will be overflowing. Next is resource allocation. Computer networks provide services in the form of network resources to the end user. The main design issue is the allocate and deallocate resources to the process. Means the resources which you are allocating to the sender and the receiver, that should be allocated same. So the transfer of packet is perfectly in optimal time. Next is statistical multiplexing. It is not feasible to allocate a dedicated path from each message while it is being transferred from the source to the destination. So the data channel need to be multiplexed so as to allocate a fraction of bandwidth or time to each host. Next is routing. There may be multiple paths from the source to the destination. Routing involves choosing an optimal path among all possible paths in terms of cost and time. Means the route path which you decide between the sender and the receiver should be optimal so that the cost and time will be reduced. Next is security. The main issue is the security. Security must be there in communication so that the sender and receiver can communicate easily and the authentication and cryptography will be possible between them so that the message which they want to transfer will not be linked anywhere in the channel. Now next is addressing. When the computers wish to communicate with one another, they need to know the address of each other. So if you want to communicate with another PC, then you should know the address of another PC. Then only you can transfer data or files to the another PC. Addresses can be of different types, such as logical address and physical address. Here, four levels of addressing are used in computer network. They are physical addressing, logical addressing, port addressing and specific address. First is physical address. Hosts are uniquely identified in the local area network with the help of hardware address. The hardware address is done at layer 2, that is data link layer. Hardware address is also called as MAC address, that is media access control address. MAC address is hard coded on the network interface cards. MAC address size is 48 bits. A MAC address is represented in hexadecimal form. Here above you can see the example of the physical address. The first 6 digits of the MAC address or physical address are identified by the manufacturer of the network interface card. These 6 digits are also called as organizational unique identifier, and the remaining 6 digit host is used to uniquely identify the network. And these last 6 digits are called as the host ID. Here you can see in figure physical addressing of the system. Next is logical addressing. Logical addressing is used in the network layer. Through logical address, you uniquely identify your host in the entire network. Logical address also separates a network from another network. Logical address are not fixed. They can be changed. MAC address are fixed, but logical address are not fixed. Logical address are also called as IP address. An IP address are of 32 bit. An IP address is divided into two parts. The first part is network ID, from which it is identified that what the host network is, and the second part is the host ID, from which the host is uniquely identified. The Internet Protocol is responsible for logical addressing. It performs two tasks. First is logical addressing and second is routing. A packet is forwarded through the routing to the right network. Internet Protocol provides two types of addressing, IPv4 addressing and IPv6 addressing. IPv4 addressing, it is of 32-bit address assigned. This type of IP address consists of 4 octet of 8 bits. Next is port addressing. The modern computers are designed to run multiple processes on its simultaneously. The main objective of internet is the process-to-process communication. For this purpose, it's necessary to table or name the process. Thus, the process need address. This label assigned to a port is called as a port address. It is of 16-bit address. Next is specific address. Some applications have user-friendly addresses. For example, specific addresses are email addresses or the uniform resource locators which you locate from the internet. Thank you.